Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over how to find the composition of a solution based on the mole fractions of the substances in the vapor phase. So let's get into this. Okay, so the first thing we want to do is let's read the question. So in this problem, we're told an ideal solution of benzene and toluene at 25 degrees Celsius contains an equal mole fraction of each component in the vapor phase. Determine the composition of the solution. At 25 degrees Celsius, the vapor pressures of benzene and toluene are 95 and 28 torr, respectively. Okay, so basically what we're given in this problem is we're given the partial pressures of the different gases, right, for a particular solution, the vapor pressures of a solution for each of the components of the solution, and they want us to find the composition of the solution itself. So it's really important to keep in mind they're not giving us the composition of the solution. They're giving us the composition of the vapor pressures of the substances that are in the solution. So we can start with what they give us to work back to the composition of the solution. So the thing we want to remember is the relationship between partial pressures and the relationship between partial pressures and moles of a gas, right? So if we go back to PV equals nRT, right? So we remember from PV equals nRT, if we have the pressure of the gas, right, and we want to get a relationship between the pressure and the moles, what we can see here is, let's see, if we divide both sides by volume, we'll get P is equal to nRT over V. And if we if we do that for both of the substances, right? So let's say this is P of benzene. We'll use B for benzene. And we'll use, for the number of moles, B. Same thing here, B and number of moles of benzene. And you'll notice that for this, if we're looking at the same solution in the same container, volume is going to be the same for each of the gases. The temperature is going to be the same for each of the gases, since it's a mixture of gases we're looking at. And of course, the R value is the same. So if we did this, we could do the same thing for toluene. So PT V equals NT, T for toluene, RT. We solve for the pressure or the partial pressure of toluene. That's going to be equal to the moles of toluene times RT over the volume. And so you can see here for both of the gases, there is a direct relationship between the pressure of the gas, in this case the vapor pressure of benzene, related to the number of moles of benzene, right? So there's a direct relationship between moles and pressure. Same thing with PT over here, the partial pressure of toluene at a particular temperature, right? So if we see here, PB, PB, or the partial pressure of benzene, is equal to N, the moles of benzene, times RT over V. If we divide these two, we'll get the partial pressure of toluene is equal to the moles of toluene times RT over V. And since the R and the temperature and the volume are the same for both partial pressures, since it's a mixture in the same container, then these will cancel out. And what you end up with is P, the partial pressure of benzene over the partial pressure of toluene, is going to be equal to the moles of benzene over the moles of toluene. So there's going to be a direct relationship between pressure and moles. So we can use that as to our advantage to help us easily solve this equation. So where do we go from here? Well, we go with the partial pressure. So here they're giving us that the mole fraction for each component in the vapor phase are equal. So the mole fraction of the toluene in the vapor phase is equal to the mole fraction of the benzene in the vapor phase. So we can use that, right? So here, oh, and by the way, let's see here. We're gonna write this out. We're gonna use that. So let me erase my board. Okay, so they're telling us that the ideal solution of benzene and toluene at 25 degrees contains an equal mole fraction of each component in the vapor phase. So using what we showed before, right? What is the mole fraction in the vapor phase? So here's my chi. So chi is the Greek letter for mole fraction. So the mole fraction of benzene in the vapor phase, this is going to be related to the partial pressure. So what is the mole fraction? Mole fraction is the moles of the substance divided by the total moles of all of the components in that substance. So here we're talking about gas, substances in gas, so that's going to be related to pressures. And so in the same way, we saw that there's a relationship between partial pressure and the moles of a gas. We could see that we can do with regard to the pressures, the total pressure and the partial pressure. So the mole fraction, if I could show you again, so if we have the pressure of, in this case, partial pressure of B, benzene, is equal to the, what was it, the moles of benzene times RT over V, we can relate that to the total pressure, right? So the total pressure is equal to the total moles, right? So if I divide this by the total pressure is equal to the total moles times RT over V, then of course we'll get the same cancellation. So RT and V cancel out, and we get the pressure of benzene over the total pressure is going to be equal to the moles of benzene over the total moles. But the moles of benzene divided by the total moles is just the mole fraction. So this is equal to the mole fraction of benzene. So we could use that. So that's going to be equal to the partial pressure of benzene over the total pressure. And we could do the same thing for toluene. It would be the mole fraction of toluene in the gas phase. Again, this is the mole fraction of the toluene and the benzene in the gas phase, not in solution. Don't confuse those two. So we're using the ideal gas law to get these relationships here. So then the partial pressure or vapor pressure of toluene over the total pressure. Okay, so now that I have these, let's go ahead and erase this. We don't need this anymore. They tell us that it contains an equal mole fraction. So what does that mean? It means that the mole fraction of benzene and toluene, those are equal to each other. So basically what they're telling us is the mole fraction of benzene is equal to the mole fraction of toluene in the vapor phase. Remember, we're talking about the vapor phase here. So if these are equal together, and then this is equal to this, and this is equal to this, and these two are equal together, right? It's logic. So that means that the partial pressure of benzene over the total pressure is going to be equal to the partial pressure of toluene over the total pressure. So those are equal together. But the total pressure is equal. The denominator, the total pressure is the same on both sides. So that if the denominator is equal to each other and the whole ratios are equal to each other, then that means that the partial pressure of both substances are equal. So that means that the vapor pressure of benzene is equal to the vapor pressure of toluene in this above the solution, right? We're talking about the vapor pressures. Okay, so this is the vapor pressures, they're equal. Okay, that's going to be a good thing to know because now we can go back to the Raoult's law. Raoult's law basically says that the partial pressure of a substance, let's say benzene, the vapor pressure of benzene or some substance is going to be equal to the mole fraction in solution. This is a different mole fraction now. This is the mole fraction in the vapor phase. Raoult's law deals with the mole fraction of the substance in the solution, right? So here we're talking about in solution. So the vapor pressure of the substance, in this case benzene, is equal to the mole fraction of benzene in solution multiplied by the vapor pressure of benzene when it's pure. So this is the Raoult's law. So we have the partial pressure or the vapor pressure of benzene is equal to the mole fraction of benzene in solution multiplied by the vapor pressure, the standard or vapor pressure of pure substance, in this case pure benzene, at the same temperature. Well, they give us that here. So they give us the vapor pressures at 25 degrees of pure, they don't say pure, but that's understood, pure benzene and toluene, 95 and 28 torr respectively. So the same goes for toluene. So the partial pressure of toluene at 25 degrees Celsius is going to be the mole fraction of toluene in the solution multiplied by the partial pressure of toluene, pure toluene, right? Not as a mixture. So using Raoult's law and using this relationship, we can now set them equal. So if the partial pressure of benzene is equal to the partial pressure of toluene at 25 degrees Celsius, then we could substitute these in for these. Logic again. So if these two are equal together, and this is equal to this, and this is equal to this, and these two must be equal to each other. So that means that the mole fraction in solution of benzene multiplied by the vapor pressure of benzene pure is going to be equal to the mole fraction of toluene times the vapor pressure of pure toluene. Okay, so we're well on our way. So we need the mole fractions. We want to know what the composition of the solution. One way to find the composition of the solution is to find the mole fractions of the substances in the solution. That'll give us the composition. So we have the mole fractions of benzene and toluene. So now what do we do here? Well, we want to set these up. So we're going to get the mole fractions on this side. So if we divide by the mole fraction of toluene, like so. So this will cancel out. And then if we divide, right, we'll divide both sides by the partial pressure or the vapor pressure of the pure benzene, right? So if we divide by that, right, so now that cancels out. And so we end up with the mole fraction of benzene over the mole fraction of toluene is equal to the vapor pressure of toluene over the vapor pressure of benzene. Okay, so now that we have this, so one thing we got to keep in mind is the mole fractions of any substance add up to 1, right? So all of the mole fractions of substance A plus the mole fraction of substance B plus the mole fraction of substance C plus ... all of those fractions are going to add up to 1. In the same way that percentages add up to 100. Percentages come from fractions. Why? Because a percentage is merely a fractional amount multiplied by 100. So all of the all of the percentages are going to add up to 100 because you've multiplied by 100. So the fractions are going to add up to 1. We only got 2 mole fractions here, so both of those are going to add up to 1. So in this case, the mole fraction of benzene plus the mole fraction of toluene is equal to 1. And so now we have a system of equations. I have one equation here, I have one equation here. I can substitute. So I can solve one of these. What did I solve it for? Okay, so in this case, I can solve it for toluene. So I can substitute the mole fraction of benzene, right? So if I solve this for the mole fraction of benzene, like so, so then the mole fraction of benzene is going to be equal to 1 minus the mole fraction of toluene. So now I can substitute this in for this. Okay, so let me erase this and give myself some room. So now I'm going to have 1 minus the mole fraction of toluene over the mole fraction of toluene is going to be equal to the vapor pressure of toluene over the vapor pressure of benzene. But I know those, so benzene is 95, toluene is 28, so I can substitute those in. So that's going to be equal to toluene is going to be 28 torr, and benzene is going to be 95 torr. And of course, the torrs are going to cancel out. So that means 1 minus the mole fraction of toluene over the mole fraction of toluene is equal to 28 divided by 95. And when I calculate that, I get 0.2947, 0.2947 Okay, now let me erase this. I can now solve this for the mole fraction of toluene. So then I'm going to multiply both sides by the mole fraction of toluene. And then I get 1 minus the mole fraction of toluene is equal to 0.2947 times the mole fraction of toluene. Now I can add the mole fraction of toluene to both sides, plus. So then this is going to be equal to 1 is equal to 0.2947 times the mole fraction of toluene plus the mole fraction of toluene. Well, that's a 1. I've got the same variable here, same thing. So I'm going to add these together. This is 1. This is 0.2947. So that added together is going to give us 1.2947. So I'm adding like terms together, and that's equal to 1. So to get the mole fraction, I just divide both sides by, 1.2947. Divide this side by 1.2947. That cancels out. So the mole fraction of toluene in solution, again, this is where we're talking about the mole fraction of solution here. At the beginning, we were talking about the mole fraction in the vapor phase. We've transitioned, once we got to Raoult's law, we transitioned to the mole fraction of these substances in solution. So if I do this calculation, I'll get the mole fraction of toluene in solution. And when I do that, I get, that is, I'll write it over here. So the, I'll write it, do I have space? Yeah, I'll write it here. So the mole fraction of toluene is going to be equal to 0.772. Now that I have that, we can go back to the other equation, right? So where did it go? I must have erased it. Oops. Sorry about that. So coming over here, remember the mole fractions are equal. So we said that the mole fraction, of toluene, where was it? Or benzene, sorry, the mole fraction of benzene is equal to 1 minus the mole fraction of toluene. So we found the mole fraction of toluene. So all we have to do is plug that in here. And so the mole fraction of benzene is equal to 1 minus 0.772. And when we do that calculation, we get 0.22, let me see, 227. Or let's say 228. Okay, so now we have the mole fraction. So if we round this to 2 sig figs, then this would be equal to 0.23 for the mole fraction of benzene, and then this would be equal to 0.77 for the mole fraction of toluene. And that, ladies and gentlemen, is how it is done. I hope you enjoyed this video. If this was helpful in any way, if you learned anything from this video, then please like the video, share the video, hit that like button somewhere over there. Make sure that you subscribe to my channel. Help me out, please. When you do that, please hit that notification bell. When you do that, click all so you'll be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you need help with, or if you have a topic you want me to cover, I would be more than happy to do that for you. Thanks for joining me, and have a great day.